In this video, I will go a little deeper into the different factors that influence greenhouse gas emissions of metal production. I discuss 4: ore grades, process energy efficiency, changing energy system, and circular economy. Ore grades. That refers to the metal content in the ores. An ore grade of 5 means that the ore contains 5% of the metal. The picture on the left-hand side shows the development in ore grades of copper from the 18th century up to now. They have gone down from higher than 10 to lower than 1. The energy needed to produce copper has gone up at the same time. The picture on the right shows this. The lower the ore grade, the higher the energy requirements. This is easy to understand. More rock needs to be mined and crushed to produce the same amount of copper. Some think this happens because we run out of the nice ores. Others say the reason is technology development. We now have the technology to also access low-grade ores at a profit. Therefore, we do. Whatever the reason, it is clearly a development that drives energy use up. Process energy efficiency is a more complicated story. Technology development usually implies that this gets more optimized over time. This then is a development that should drive energy use down, not up. However, there are limitations to that as well. A certain amount of energy is always needed to extract and refine the element from its ore. We can't get any lower than that. Then there is the relation between energy use and greenhouse gas emissions. This also changes over time. The whole idea of the energy transition is that we will be able to produce energy with much lower levels of greenhouse gas emissions. So it may be that we use the same amount of energy to produce the metals, but actually with much lower greenhouse gas emissions. Here you see the developments in greenhouse gas emissions per kilogram produced metal in 2 different scenarios. The market's first scenario is a business as usual scenario with a slow uptake of renewable energy technologies. In the sustainability first scenario, the energy transition is supposed to be realized to a large extent. And this indeed shows lower greenhouse gas emissions per kilogram of metal. Especially for the more energy-intensive metals such as aluminium, emissions can actually be halved. Last but not least, what about circular economy, recycling, secondary production of metals? Well, here we have something that really would make a difference. These figures are self-evident. It takes much less energy to produce these 7 metals from scrap than from mines. If we were able to couple the energy transition to a circular economy transition, this could really make a big difference and be a large contribution to reducing climate change at the global level. For critical raw materials, it is less straightforward what the consequences of these trends and developments would be. We do know, however, that improving the energy efficiency of production processes as well as the greenhouse gas emission efficiency of energy production should make a difference for these materials as well, and that closing loops should be a focus for these materials as well. If their markets are so unstable that this can't happen, in my personal opinion, the material is destined to disappear from the economic stage in due time.